So in today's video, we're going to be looking at a velocity time graph, and we want to be analyzing it and try to get as much information as we can for a beginner level. Now for velocity time graph, not so easy to analyze, but we're going to come up with an easy way to do this by thinking about Sonic the Hedgehog. So let's draw Sonic. And for Sonic the Hedgehog, what is the main goal of the video game? Well, he runs around trying to collect the gold coins. But you can imagine that as he runs towards the gold coin, he's going to slow down because he's getting tired. But once he gets the gold coin, it kind of makes him feel good about himself, and he's going to be able to speed up again. So we're going to use that analogy to think of the zero velocity as a golden ring. And whenever Sonic moves towards it, we're going to think that he's slowing down. And when he gets it and moves away from it, he's going to speed up. So now it's a lot easier to look at his velocity time graph and tell, hey, what kind of motion is undergoing in each section. So in this case, we don't have any labels, but this should be the negative velocity values. This should be the positive velocity values. So in the negative velocity values, notice that as the time moves forward, the graph is approaching the ring. So what do we say about the golden ring? Whenever Sonic approaches it, Sonic is going to be slowing down. What happens once he gets the ring, which is at the origin? The velocity is going to be momentarily at rest, because he's going to feel good about himself. He's going to have a quick thought like, oh my god, my life has meaning. So in this case, once he gets the golden ring, he's going to be momentarily at rest. And once he gets the ring and moves away from it, we can say that he is speeding up. So in this section of the graph, he is speeding up. Now, of course, you have to imagine that he can't speed up forever, because then that would make sense with this analogy, right? So eventually he will have to slow down and repeat the process, but for short intervals of time, this analogy will make sense. So when the velocity gets closer to zero, we can say it is slowing down. When the velocity is zero, it's momentarily at rest, and when it moves away from zero, it is speeding up. But now we have to do better, because the direction actually makes a difference. So if we recall, whenever the velocity was positive, we said that the object is moving in the positive direction motion. And whenever the velocity was negative, the sign indicated that the object was moving in the negative direction. Alright, so now we can tell a better story, because whenever you're describing the motion of Sonic, or anything, you have to specify the type of motion along with the direction of motion. So in the first interval, it is slowing down while moving in the negative direction. Momentarily at rest, then begins to speed up while moving in the positive direction. So if you're going from negative direction to positive direction, what happened at the moment that Sonic was momentarily at rest? There was a change in direction of motion. Alright, so this is how you can easily analyze a graph with this analogy. Hopefully it serves you right, and you can answer any physics question. So stay tuned, I'm going to show you other examples, and they're going to be more complex. Thank you, Sonic, for helping us out.